Leak testing the condenser of a condensing steam turbine. First, we have to ensure things are locked out and tagged out the way that they're supposed to be. This is the steam outlet from the turbine. It is locked and tagged in the closed position. The blue lines that you see here are the gland steam exhaust lines. They lead to the condenser steam side, so they too must be locked or tagged in the shut position. Notice too that the condenser water is isolated and locked shut. The water boxes must also be opened up. The condenser must be vented and drained. That's the water box vent. As part of the lockout and tagout procedure, the electrical equipment must also be locked out and tagged. The condenser hot well drain must be shut. The condensate pump and the condensate lines must also be locked and tagged in the shut position. Both sides of the water box have been opened up for inspection. Now that the condenser is completely isolated, an opening at the top of the condenser for access to the steam space is uncovered, flange is removed, and a hose is inserted so we can fill the condenser and the steam side with water. In order to determine if there's a leak, fluorescein is added to some water, and this will make a glow-in-the-dark solution under black light. The fluorescein solution is added to the top of the condenser into the steam side. More water will be added until the condenser is completely full. Then we'll wait a little bit of time and determine if there are any leaks on the water side. Water is added to the condenser steam side until the steam side is full. In order to successfully do a condenser leak test using fluorescein, the tube sheets must be completely dry. The water, when exposed to black light, will glow green. The tube sheet is examined carefully under black light. Any place where glowing liquid is visible indicates a leak. Right now you can see some residue from the internal baffle, which is giving us a false indication. Here you can see a tube with a slight glow inside of it, right in there. And that slight glow, that greenish glow, indicates that there is some seepage. So the location of the leaky tube, right there. It's a very slight leak. There's another tube that showed some indication of leaking at the other end.
Oh, you just opened that? Okay. Is there like a bigger...
At the end of the condenser leak test, we're going to try tightening the ferrule to stop a slight leak. After which, we will drain the condenser using the hot well drain.
Coming out, Dad?
Yeah, but very slowly, right?
Really
Then we'll refill it with water, drain it again, fill it, drain it again. The idea is to get rid of the fluorescein that's left behind inside the condenser. Once the condenser is flushed out, we'll restore the lockout by opening the discharge valve, opening the gland steam exhaust valves, new gaskets are being made for the water boxes. The plates will be reinserted, the baffle plates. A new gasket will be fashioned for the end plate. We'll get the belt guard back on the condensate pump. Restore the lockout on the discharge valves on the extraction pump. This gasket surface will be cleaned, leftover gasket material, and a new gasket will be made. And the electrical to the extraction pump will also be restored. The students are taking this as an opportunity to tighten any loose ferrules.
They were at the other end.
Oh, right, yeah, they usually know the drain. That's the only part that, and that's the best, that's very, yeah.
No, you might get. I don't want to miss it.
After tightening all of the ferrules, RTV silicone was placed where the baffles seat. That will keep water from bypassing the baffles, ensuring that it goes through all of the passes. This condenser is a 5-pass condenser. New baffle plates made of plastic are inserted. There's adequate expansion at the ends of the baffle plates to allow for differential expansion of the plastic baffle plate and the shell. A copper pipe has been sliced partly through and snugly attached to the plastic baffle to stiffen the plastic assembly. Then a bead of silicone is placed over the edge to provide positive sealing. When the water box end plate is put in place, the end plate is divided up into quadrants so that when it's tightened, it will be tightened evenly. One quadrant, tightening one nut from one quadrant at a time in a crisscross fashion.